All right, so I have shared the registration link. So just click on the link. I'll continue to reshare because apparently when somebody joins, then they won't see what was posted before. So I'll share it again. And if you just join, just click on the registration link and complete the registration process for me. For those who just joined, I was saying that I have shared some information as it relates to free certification with Google. Share that in the WhatsApp group. If you're not a member of the WhatsApp group, just take this number down, send me a message, and I'll add you. I'm typing the number in the chat section. So if you're that is my number. So if you're not in the WhatsApp group, you can just take that number down, send me a message, and I'll add you to the WhatsApp group. Also, we have CSEC and CAPE chemistry. Do we have anybody here visiting chemistry or social studies? If not, just type in the chat section and let me know what subject you would like us to do, which other subject would be beneficial to you guys in terms of HSB. All right. Anybody else? So we're trying to get the feedback from you guys so that we are better able to assist IT. All right. So we have one HSB, one IT. Persons who are on social studies. All right. So Brandon, the social studies class would be good for you. You know, 2 HSB. Brandon, did you see the flyer for social studies? I'm sure I posted it in the maths group. What else? We have 10 people on. Is it that everybody else is only sitting math? I want to know which other free class. I didn't, but I'll check. All right. So let me double check to see if it's there. Which other free class would you like us to host that would help you with your upcoming CSEC? Which day? Chemistry. All right, let's see. So the chemistry, you guys not checking the group, you know. So the chemistry flyer here. Flyer for chemistry. So for chemistry is Thursdays 5 to 6. Social studies. Let me check. You know, it don't look like I posted the social studies one. Nope. Let's see. All right, so I'm just looking for the social studies flyer to share in the WhatsApp group for those persons who would be interested in the social studies class. And it's also on my status as well. So the social studies class is Thursdays as well, going to start this Thursday, and that is 4:30 to 5:30. All right, so I just shared the social studies flyer in the math group. So everybody on, you're fine. You don't need any other. So I see 2 HSB. Right. See, somebody found it there. So it was actually there. 2 HSB. All right. So we look into that. We look into that to see if we can find somebody to facilitate the human and social biology class. All right. So we're just waiting on Mr. Stevenson to join. Is there anybody on that is job hunting? Or do you know anybody, family member, so forth, who is looking for job opportunities? You might be wondering, why is, why is this, why is sir asking about job opportunities, and this is maths class. So Mr. Stevens, right? Social studies, all right. So Mr. Stevens is your math teacher, but my job is to provide opportunities for, Selena. My job is to provide opportunities for young people, but our age group is 15 to 29. However, we may extend to assist other persons. There is one link that I don't think a lot of Jamaicans know about. It's very useful and effective. You can go and look for jobs. You can actually upload your resume on that page. A lot of recruiters uses the page to look for suitable persons for job positions. I'm going to post the link for that page now. And guys, just so you know, Mr. Stevens is on. I guess he's just giving me a little bit of time. All right, so I'm going to post the link. And when you go to the page, it's going to show you jobs, career development, employer resources. And I just advise you to go through the different tabs and look and see. So I'm going to post the link here now. And you can use this link to look for jobs in your area. Doesn't matter where you are in Jamaica. And you can also upload your resume, because persons who are looking for employees utilize this page a lot. All right. Somebody else is joining on. Also, I think this one is Contacts 360. Hold on. Let me check to make sure. This place is taking on persons. Just give me a sec. Let me type the correct information. So for those who are just joining, I'm just sharing a bit of information as it relates to job opportunities and so forth, while Mr. Stevens was having a little bit of technical challenges. So we're just giving him a few minutes to get that sorted out. So I'm sharing opportunities for careers and training. So for the training, I shared that information in the WhatsApp group, but for job opportunities, I'm sharing that here. So that's contacts360.com. And if you apply to contacts360.com, please send me a message. Send me a text message with your name, I'm typing it in the chat, date of birth, address, contact number, email, age. Once you apply to Contact 360, just WhatsApp me this information so I can make a call for you on your behalf, so that somebody that I have there will look out for your resume. If you are not job hunting at the moment, you may know somebody who is trying to find a job. Share the information with them. We have so many persons who have been displaced because of COVID and are not working. So share the information with them. For those who are just joining on, I'd asked previously, for those who would be interested in another class, free, just the same. If you're sitting another subject in CSEC, we have two persons. Well, the dominant request is human and social biology. Somebody said social studies, but we're offering a class in social studies already, and that is every Thursday, 4:30 to 5:30. If you're interested in another class, CSEC class, let me know. Just type it in the chat and let me know. All right, Mr. Stevenson, where are you ready? Mr.
Yes, man. I'm here.
Are you just getting your stuff together?
I was always ready, What happened?
Yep.
What happened?
Okay.
I went on the road and I came in exactly 4:30, and my phone my phone was off, and when I plug it in, and you were calling me, you know.
Okay.
But I don't mind the additional information that you are
Right.
disseminating to the students, you know, because let me tell you, information, knowledge is power, you know, and when you don't have knowledge, you suffer. Because a lot of students don't know about these things, you know, they're just at school. Sometimes the parents they're not up there, you know, they're just hustlers, and anything will come and work out, the others for them think that. So I you know, you're just doing your job, and so I give you some time to just do what you need to do.
Yeah,
You know?
man. Because I've seen so many young persons, you know, you are going to school and you're doing your C-Sec and so forth. And if somebody should ask you, and this is a question that I ask a lot, why are you going to school? To learn. Yes, to learn, and to do what with it after you learn. What career path have you, you know, chosen? You're doing the subject, what is it that you want to do? Many you don't know. So for the maths class, and if you guys, I'm just putting it out there, if you want a session one day in career development, just to help you to maybe solidify what it is that you really want to do, because I am certain if it is even one person in the class right now, you are not 100% sure what it is that you want to do. So if you'd like a session in career development, or you know, just some little advice as to how to select a career, you don't have to type it here. You can just message me, and you know, I'll make that happen. For those who just joined, I just shared the link for the register. I'm going to post it in the WhatsApp group as well. Please complete the register, guys. All right, without further ado, Mr. Stevens, I'm going to turn over to you.
Yes, sir. All right. Okay, so good afternoon, everybody. Sorry to be a bit late. So we're going to today we're going to go through some Pythagoras and basic trigonometry. All right. So I'm just trying to see. Mr. Green, sometimes at the last time I presented something using Google Meets.
Yes.
There was no audio on my end. They said they're not getting any audio. Do you know what you do to check to see if
Okay, so there's a process. I am going to share the video. I did it one time for my son's teacher, because when you're sharing, like say from YouTube, there's a process that you have to go through to enable the secondary audio for the persons who are on for them to hear. I don't know it out of my head, but the video is on YouTube.
Oh, the mercy! So you know, nothing like where you go to settings, or
I don't remember. All right, just give me a sec. Give me a sec. Let me look for it real quick.
All right. Okay. All right. So while Mr. Green is looking, do we have any newcomers in today's session? Anybody here for the first time? All right. So I guess it's just the old time of them. Just joking. All right. So yeah, so today we're gonna review some Pythagoras theorem and basic trigonometry. All right. I have a little all right, tell me if you're seeing what should we be seeing? Are you seeing my screen? Are you seeing something about 60 Math PowerPoint presentation part A?
Yes, sir.
All right. Okay. All right. So this is an actual project that I'm actually working on. But the last time it was showing something on Google Meets, there was no audio, and I just don't know All right. I'm gonna ask something. Tell me if you hear something. Just tell me if you hear hold on here. It should be coming up right now. You guys hear something?
No, sir.
Oh dear. All right, that means that I need to go back to settings. But why is this thing so difficult? It shouldn't be that complicated.
All right. When you're going to share the video, look if the presentation audio is on.
Oh, hold on. Let me. All right. So as a present, oh, you're right. You know. By the way, where do you go to? Where would you view that? All right. You're seeing my. Okay. What you're seeing is my screen, right? Because I'm still.
Stop presenting. Click on here. Click stop presenting. Go back.
All right. Let me share my screen.
Really, really easy. That's how you share a YouTube video.
So you want to share a YouTube video, right?
No, hold. All right. Yeah. All right. So this is my screen now that you're looking at.
Right.
So I should go to. Oh, I shouldn't have done that. I would have to go back. Not true.
Well, once you click on sharing, you should see an option there for presentation sound.
All right, let me stop presenting. I am not seeing it, you know.
All right, hold on.
I'm not seeing it. I'm just seeing share.
Hold on. Let me try something. Are you guys seeing my screen?
Yeah, I'm seeing your screen.
Oh, tell me if you can hear.
If this is Sadie,
yeah, I can hear.
Going to share that now. That will come to the forefront of the window.
Can you guys hear?
Actually control the YouTube video is in that window.
Yeah, man, I'm hearing.
You can see now that I'm presenting here.
All right, so where it says presentation audio.
We're going to get a little bit of an echo when we share this video.
So I don't know. It should be the same from your end too.
So when you do that, do you see yours? Do you see it?
I actually don't see the presentation audio thing from my side, you know. I don't see it.
All right. Let me not stress yourself because time is going. So let me just run without it. So all right. So this is my screen now, and I have a PowerPoint, but it have some little videos and stuff in it, you know. So that's what I wanted to share. All right. So let me just skip through that. All right. So we're gonna go through Pythagoras theorem. And you guys saying you're not hearing anything, right? All right. All right. So all right. So let me just skip through that. Okay, so the importance of Pythagoras theorem. All right, so basically, by the way, everybody's supposed to have a basic knowledge of Pythagoras theorem, right? I'm assuming that. I think from grade 9 or grade 8, you probably should have learned that. Is that so? Or grade 10? Is everybody familiar with Pythagoras theorem?
Yes, sir.
All right, cool. So we're just doing some recap. So it says importance of Pythagoras theorem. So Pythagoras theorem and trigonometric ratios can be used to solve real-world problems. So a lot of issues, especially in construction, design, what do you call it, structural engineering. We use that kind of mathematics. All right. So real-world phenomena also can be represented by our modeling using concepts relating to right-angle triangles. Engineers and architects use Pythagoras theorem in their daily duties to assist them in their calculation of measurement and also to solve complex constructional problems. All right. Any of you guys ever watch Modern Marvels on the History Channel? Or any footage or any documentary with, and they tell you how these mega construction, these mega buildings were designed from start to finish. Anybody ever watch anything like that before? No? All right. I guess I'm getting old. But all right. But if you watch these videos or documentaries, what they do, they take you to the process of how the whole engineering aspect, the architectural design, the construction of these mega buildings. Here in Jamaica, we don't have a lot. Not necessarily in Montego Bay. You probably see them. Well, mega constructions. You probably see like the hotels. But if you go to Kingston, New Kingston, downtown Kingston, you see a lot of high-rise and commercial buildings. And these buildings, the basis of construction is based on mathematics, Pythagoras theorem, trigonometry. All right. So it is very, very important. All right. As a matter of fact, let me tell you something. You see, when you build, you see the corners of your house, the foundations of the house. When you're building a house, the corners are very important, the columns. All right. And to get those columns at exactly 90 degrees, it's very important. Because you don't want to build a house and the corner, one corner 80 degrees, one at 60. What's going to happen to your house? It's going to look away and it might crumble. It's going to lean, it'll crumble, not true? Yeah. So, have you guys ever looked at like at a whole, like a newly constructed housing scheme, and you're at a pavilion or at a high altitude and you're looking down, and you can actually look and see that the houses are exactly at the same height, the same width, everything is just super perfect. Yeah. I can tell you that when I'm going to work at school, there's a housing scheme right below me, and at one point I was looking at the roofs and I realized that all the roofs connected, and what I was looking at was like a big long carpet of roofs, and it was pretty amazing. All right, so in construction, Pythagoras and trigonometric ratios are very important. All right, and even the corners of your house, then you come on the way, see a layer block when I go to university, they have to use Pythagoras to get a perfect 90 degree for the angle. All right. Okay, so moving on. All right, so look at this now. So in a right angle triangle, right? Well, Pythagoras deals with what? Only right angle triangle. And the longest side of a triangle is called a, what's it called?
Hypotenuse.
Right. And I put in this don't be offended, right? This is actually a project I'm actually working on, you know, a personal thing. Not for teaching purposes, but I guess you can probably use for that. All right. All right. Now, if you look at the diagram, what is it telling us of how to identify the hypotenuse?
Opposite to the right angle.
Right. So the hypotenuse is always opposite the right angle. What about the sum of the interior angles of a triangle? What is that equal to? If you're to add up all the angles, the interior angles of a triangle, it must add up to, anybody knows?
Sine of 360.
No. All right. So if you're to add up all the triangles, all the angles of a triangle,
180.
180. Right. Very good. All right. You see, for the 360, it will be a quadrilateral. So like a square, a rectangle, a trapezium, any four-sided figure that would add up. That would add up to 360. All right. Okay. So these are some more points about Pythagoras theorem. So in Pythagoras theorem, look at this point here. Pythagoras theorem only find unknown sides. So they only find sides. All right. And in this thing here, sometimes they use the word leg. So sometimes they don't use the word sides, they use leg or legs. All right. All right. Now, what is Pythagoras theorem, by the way? Now, point number 3 here states that it is the sum of the squares of the two short sides, and that is equal to the square of the longest side, which is the hypotenuse. So basically what they're saying, if you're to square the short side, one of the short side them, square the other short side, add them, then it will give you the length of the longest side, which is also called the hypotenuse. All right, everybody following so far? Any questions?
Yes, sir.
All
No.
right. All right. Okay, so, oh, by the way, is in a right angle triangle, if the hypotenuse is the longest side, then the other two sides must have been the short sides. So in a right angle triangle, you only have one side that is the longest side, and the other two sides would have been the short sides. All right. And while we're talking about triangles, now we have different types of triangles, but because Pythagoras theorem only deals with right angle triangles, I will be just focusing on right angle triangles. And one important feature about a right angle triangle is that it must have a what?
Right angle.
Right. It must have a right angle. Otherwise, it wouldn't be called a right angle triangle. All right. Okay. Okay. So continue with Pythagoras theorem. So this is the mathematical representation of it. So we said that it is a sum. So let's go over this side here on the right hand side. It is a sum of the squares of the two short sides, and that is equal to the square of the longest side. All right. And we have this formula here. So c squared is equal to the square root of a squared plus b squared. Now we can rearrange this formula to find a short side. So we can rearrange this to find side A and side B. All right, so these are some interesting facts about Pythagoras. Anybody want to read the first point for me, just to participate?
He lived in southern Italy during the 6th century BC.
Thank you very much. All right, so that's a long time, true? Yeah, man. All right. Anybody else want to read the other point?
He was considered the first true mathematician.
Right. All right. Anybody else wants to take on the third point? Anybody else want to read the third point?
He was first to teach that the earth was a sphere that revolves around the sun.
All right. That's interesting. That's true. How many of you guys knew that? Honestly, I didn't know. I didn't know that. You know? All right. As a matter of fact, what are your thoughts about persons saying that the world is flat? You guys ever like take on that and think about it? And like wonder what the hell is happening? Why are they even talking about that? All right. So you have a bunch of people who have that idea that the world is flat, you know. And I'll just take on the last part. So he proved the Pythagoras theorem and he named it after himself. All right. Okay, so those are some of the interesting facts about Pythagoras. Have you guys ever heard this term, the shortest distance between 2 points, a straight line? All right, so it was actually Pythagoras theorem that they're utilizing. The shortest distance between any 2 points, it will have to be a straight line. All right, so let's look at this. So we want to find the value of A. So number one, is it a right angle triangle? Yes. Secondly, you know, do we have two sides and want to find another side? Yes, that's another condition. And you have to recognize this here, because when you move on to trigonometry, you will get questions. Questions will appear to you like this, and you have to know whether it's Pythagoras or whether it's trig ratios. All right. No, it's because we are actually doing Pythagoras, and I'm giving an example. In your mind, it's a boy, most Pythagoras we're gonna use. But what is here in an exam? And a question like this is just given to you. You have to like evaluate and assimilate all the ideas on how to approach this question. So the first thing that comes to your mind, you identify and say, okay, you know something? Pythagoras only deals with what? Right angle. So you triangle, right? So you check that. And also, additionally, is that in order for Pythagoras to work, you have to have two sides, and you use the two sides to find the other sides. All right? It cannot work no other way. They have to give you two of the sides. All right, so let us go back. Right, let's go back up here. So you notice that they give you a list of formulas, right? They give you a list of formulas. So actually, you know, something is not, this should actually be C and not C square. I need to change this. This is actually C. All right. So C is equal to the root of A square plus B square. And if you want to find a short side, you do the same thing, is just that you subtract. All right, and we're looking at this example here. All right, so this is what they're gonna do. We're gonna the approach that we're gonna take, you see, is to use this is to use a square plus b square equals c square approach. We're not gonna jump on these formulas. So we're gonna use a square plus b square plus c square. Now, what does a and b represent?
The leg.
Right.
The short side.
Right. You have to be specific. It would have to be what? The short side, not true? All right. And C would represent which side?
The hypotenuse.
The longest side, which is the hypotenuse. So you need to know which side we are looking for, you know, because the formula might change up, not true? All right. Okay. So let me ask a question. We're asked to find A, which is the hypotenuse, which is the longest side. So we're gonna use A square. A square is equal to what? B square plus C square. All right. So it's gonna be 4 square plus 6 square. Everybody see that? I'm
Yes,
using.
sir.
Let me go back. Let me go back. I'm using this formula here. So that's a general formula. A square plus B square equals C square. Or you could actually spin it around and say C square is equal to A square plus B square. All right, so A square is equal to B square plus C square. So B is 4 and C is 6. Now it doesn't matter which side you label A, B, or C. It doesn't really matter. All right. All right. Now, what is 4 square?
16.
16, not true. And what is 6 square?
36.
36.
All right. And what is 16 plus 36?
52.
All right, 52. All right. Is that the answer though?
No, sir.
No, sir.
All right. What's happening? What am I missing out?
So you have to square root
You know, find
the
A.
52.
Right. Very good. So A square is equal to 52. All right. So for us to get A, we would have to square the left and square the right. In other words, we would have to find the square root of what? 52. And what is the square root of 52? Give that to one decimal place.
7.2.
Very good. Okay, it's disappearing. I don't know how to get it to stop it like that. So the answer is actually 7.2. Any questions? Anybody writing this off?
Finish.
All right. Anybody else? All right. So remember, you know, the side that we just found was a what? A long side, don't you? All right.
Yes, sir.
So let's move on. I mean, let me tell you, these questions can get really complex here, but I'm just starting off with something pretty simple. Okay, so let's look at this question here. It's actually worked out for you. All right, let me just give you a minute to take down this diagram, a minute or two to take down this diagram and take down the solution. And I want somebody to walk me through what's happening. What's happening right here, so. All right, so the next 2 minutes. I'm going to step away for a minute from the computer. All right, I'm back. All right. Anybody want to take a shot at this and explain to me what's happening here with the working out? Well, it's different from the first one, not true?
Yes, sir.
It's different. Can somebody tell me what is the difference?
Sir, explain it or tell her what is different.
So you find the short side, so you have a print out.
All right. Okay. So okay. So all right. I'm not gonna. You want to explain it now? Are you ready?
Yes, sir.
All right. Go ahead for me. What's your name?
Daily.
Daily. All right. Cool. And Daily, which school are you representing?
Petersfield High School.
Okay. Go ahead. All right. Very good.
Sir, so first we're going to find, no, first we're going to say 6 square is 36 and 3 square is 9.
All
So
right.
you're going
All
to
right. All right.
find,
Miss Daily, before you do the go to there, so I want you to explain to us how explain to all right. Like, obviously the question. Oops. Sorry. Sorry about that. Sorry about that. Let me go back. All right. Well, obviously the question is not there. The question says to find x. Not true. Right. So I want you to explain to us the first line, because that's very important. How did I arrive at that first line?
sir, because the hypotenuse is 6 cm and that is the long side and the short side is x square plus 3 square.
And t square. All right. Cool. Right. Right. So let us go. Let's look at this one. Okay, so something is not right here. Something is acting up. I'm trying to go back to this one. Okay, I'm looking for the solutions, but it's not coming up. That's strange. But the first one, was what? A square equals what? 4 square plus 6 square. Not true?
Yes, sir.
Right, but no. And the reason why, and the reason why we start off with, oh, there it is. No, there it is. So it's a square equal 4 square plus 6 square. And let me just take you back. That this is what Pythagoras theorem is all about. All right? So, all right. So everybody understand why the formula is like this? Why is it 6 square equals x square plus 3 square? Because this is the rule of Pythagoras' theorem. What Pythagoras said, if you're to add, see the add here? Well, let me go for the marker. If you add the sum of the squares of the two short sides, so x and 3 would have been the what? The short sides. And 6 would have been the longest side. All right. So, Ms. Daly, go ahead for me. Continue now with the second line. Do you know what I'm doing?
Yes, sir.
All right, go ahead.
Sir, then the second line is taking away is subtracting the hypotenuse from the leg. That is the short side and the long side.
All right. And in particular reason why I'm subtracting 3 square from 6 square?
Yes, sir, because I want to find x square.
Right.
The value of x
Very
square.
good. Very good, Ms. Daly. It's upon the top line. I want x squared. I want x, not true. So I don't need a plus 3 squared. So I'm going to subtract 3 squared on the left and 3 squared on the right. Continue. You're doing well so far.
Sir, so 6 square is 36 and 3 square is 9. So you're going to subtract 36 from 9 equal x square, and the answer would be 27.
Well, x squared is equal to 27, and then you'd have to find the what? The square root of x, or the square root of 27, which is 5.2 decimal, 5.2 centimeters. All right, students, any questions? All right, thank you very much, Ms. Daly. You represented Petersfield very well. All right. Do you have any questions about this? All right, let's look at this question. So take down that question with the solution. Excuse me for a second. Hello. Yes. The ball. Wait a second. Who's the boss? Oh, her name is Mrs. Carol Clark. Right. You have to go to Dome. You know where Dome Street, the Dome Street offices. Right. There's you know where Overton Plaza. Oh dear. All right. Just gonna direct you to Overton Plaza, and just ask them for the Heart office. It's right beside UTech, Montego Bay campus. No man, that's UE. That's owned by UE. Yes. All right, I got. All right. Oops, sorry about that. Sorry about that. Wait, what happened to this diagram? The diagram is not staying. I don't know what's happening. Whoa, it just vanished like that. Is that? I need to double check this thing here. All right. Hold on. Let me. All right. Let me use that angle. All right. Anybody want to walk me through this? What's happening here? Anybody want to explain what's happening right here, so with this question here? No. Someone tell me what's happening. Somebody describe this question to me. Like, what's really happening? What do you observe about this question, basically? All right. Nobody, you guys are not really sure? All right, so somebody wants to participate? All right, so basically what's happening right here is that it's like you have two right angles triangle, not true? And one is stacked on the other one. That's basically what's happening. Imagine that this is a ladder. You see this here? Imagine that to be a ladder. This is the ground and this is the wall. So imagine you put a ladder on a wall and then this is another segment of the wall and you add another ladder. So that's what's happening right here. We're stacking up two right angle triangles. All right. Now, the question, in this question, we want to find x and y, basically. All right. We want to find x and y. So what they did was to use Pythagoras theorem and find y. Question, is y a long side or a short side?
Long side.
A long side. All right. How do you know? Nobody attempts because it look long. How do you know definitely it's a long side, the longest side?
Sir, because it's the hypotenuse.
Okay. Why is it called the hypotenuse? How do you identify it's the hypotenuse?
Because it is on the opposite side of a right angle, sir.
Right. That, let me tell you something. It's because sometimes these diagrams are not drawn to scale. They're not drawn to scale. All right. Let me ask. To be honest with you. Look at my cursor. Look at this line here, where the y is, and look at x, and tell me which one you think look longer. Or if you want to be frank, would you agree with me that x and y look like the same thing? They might not look like the same thing, but they look pretty long, not true? And we're not positively 100% sure which one longer. So to reduce the speculation, and because these diagrams are not drawn to scale and we can't take a rule and draw it, we have to use another foolproof method to identify the hypotenuse. So the hypotenuse is always opposite the what? The right angle. And because y is a long side, we're going to use this method here of adding. So y squared is equal to 4 squared plus 4 squared, which turns out to be 16 plus 16, which turns out to be 32. And we find the square root of 32, which is 5.66 to 2 decimal place. All right. Any questions so far?
Sir, could you repeat, please?
All right. Let me run through it again.
Just one of them.
So what happened here is that we have two right angles stacked onto each other. All right. And in this question, we're asked to find x and y. But to find x, well, we can't find x. Can you tell me why we can't find x first? Why is it that we have to find y first? Some of you might be saying, boy, sir, I'm asking some obvious question, but it's important. Why is it I can't go ahead and find x first?
Sir, because it doesn't have a short side.
Right, because guess what? X is connected to this triangle here, not true? And we only have what? One side. And you can't use Pythagoras theorem if you only have what? One side. We need to have two sides to find another side. So that's why we can't find x first. So what we're gonna have to do is to find y. All right, and we use Pythagoras theorem to find y. And then no, is y a long side or a short side? It's a long side. So we add. So y squared is equal to 4 squared plus 4 squared, which is equal to 16 plus 16, which is equal to 32. All right, and then we square root that, we get 5.66. So y is equal to 5.66 centimeters. All right. Anybody want to walk through with this question of step 2 of finding y? Sorry, finding x. What are they doing? What's happening to find x?
Sir, they used the value of y plus the 2 centimeters.
All right, so you're absolutely correct. The y value that you just worked with a while ago, you see? We're going to use it with the what? The 2 to find x. All right? Now, is x a long side or a short side? It's another long side. Right. So therefore, we're going to have to add. So we need to know the two, because if it's a short side, we are finding, we're going to have to subtract the two. Yes, man. Anytime one time a long side we want to find, we add. One time a short side, we subtract. So there we go again. We say x squared is equal to 5.66 squared plus 2 squared, which is 36. And the square root of 36 is 6. So x is equal to 6 centimeter. So this is actually this modeling here. It can be used as a project, you know, because it could stack another what? Triangle. All right. So, any questions? Okay, so let's go to this. Can you guys see this? All right, let me. I actually did this as a project, you know, this activity here. I actually did it as a project. So basically, it's called, I should have shown you a video. All right, tell you what, the problem, you know, the problem with that I have is that the video, there's no audio, but I'm going to show you.
I think I can't tell you what to do, but all right, so let me just go through real quick, right?
All right, let me stop share, because I would have missed out a lot of information with the videos, because they're kind of connected, you know.
All right, so you have to do the from your browser.
Mm-hmm.
All right, hold on.
Boy, this is a big drawback for Google Meets. You know, it shouldn't be something that you have to, you know, it should be something that you could just, like, you know, easily find a way through. Mr. Green, are we using a
okay? I was thinking about that. I realized that. All right, so you're going to go to your Google browser.
You mean
just on the tab, maybe like if you have your email open or so.
Okay.
Or
So
even on this page, you should see to the top right hand corner, you see three dots.
Okay. Oh, oh my. Hold on.
Are you using your phone?
No man,
Okay, good.
my computer. It's just that I can't. I don't, I don't remember where to go but to find back the.
You can
Oh,
use
okay.
this page at your hand, you know.
Okay. Yeah, I'm there now.
The three dots.
Yeah, 3
All
dots.
right, just click on the three dots and then scroll down and click on cast.
All right.
All right, so you should see a little icon on your display area.
Yes, I see cast. Right, that's a little icon.
All right, right click on the icon.
Well, okay, I'm seeing okay. Nothing is happening.
When you right click on the icon.
Okay, all right. Tell you what, when I go to cast, right? When I go to cast, something pop up and says castmeet.google.com. It says no devices found.
All right, so just close out of that, man. You're just going to right click on the icon that is there. You have to close that. Just
so don't.
No. So the icon that is on the display area. Right click on that icon. Not seeing anything. You see a little square there, and to the lower left side, it looks like, you know, there are some little mini circle there. The cast, you see the cast icon?
Yeah, I'm seeing cast.
So right click on that icon.
Hold on. Let me go again. 3 dots. Highlight. I'm at the 3 dots. Highlight.
Just left click on cast.
Right.
So you're going to see cast. Right. So just click on the X that is there and close that.
So I close that.
All right. Now, so on the display area, you should see a little square. Not seeing it?
Why have to go share your screen?
All right.
See that. All I'm seeing is that it says cast meet no device found.
All right, hold on. All right, so you see my screen?
Yeah, I'm seeing a screen now.
All right, so you go here and you click on cast. So you're looking for this icon right here. You're going to close. This icon should be on the screen.
Hold on there. All right, let me. So click on that. What are you clicking on?
Right click on it.
Oh. Let me try it. One more time. Cast. Boy, Mr. You come next for my computer and I have that something there, sir.
All right, tell you what. So let me just continue, and then for the next class, because I sent you the step by step. I sent you the video and the step by step.
Hold on. When I right click, okay, I'm seeing something come up now. I'm seeing about learn more help.
Right.
Like
when I left click it, I left click before, you know.
Oh yes.
No, right click. So you should be. Are you seeing enable cloud services?
Right.
Click on enable cloud services.
Left or left, right?
So you're going to left click on enable cloud services.
Right. And enable it.
Yes.
Okay.
It should be good now.
Boy, I tell you. Man, I would never figure that out.
Yeah, it's kind of a bit technical, but
Yeah,
it should be good. I can try it now and see.
yeah, okay, let me test it out. Sorry about that, class. It's one of those things. All right, so okay, as I was saying, we were looking at this question, right? And it was one triangle stacked onto the other triangle. Now, what I'm going to share with you is that there's actually, you can actually design stuff. Did you know that you can use mathematics formulas and design stuff? All right, let me just test it. Let me test the audio. Tell me if you hear something. You guys hear something?
No, sir. Oh, yes.
Oh, you hear something? Oh, finally. Good, good. Finally,
No,
Cam.
sir. No, we're not hearing it.
No, because I stopped a while ago. Are you hearing something now?
Yes, sir.
All right, good, good. That means we're good. All right, cool. All right, so I'm going to show you a little video in which we can use mathematics to do some design. Sometimes we do art and craft and, we just go and paint something, but you can actually design stuff mathematically. All right, so come on, don't slope on me.
Start with 11 by 17 centimeters. From the left side, make a white mark. Line up your ruler at the top of your page.
Sir, I'm not hearing if the person is talking.
You're not here?
No.
Lord of mercy.
From the left side, make a white mark.
Boy, I'm sorry.
Sir, you can turn it up a little louder. You can hear, but it's not loud. You
Oh.
can't make out what is being said.
Yeah, what if I try to turn up my computer volume?
Yes.
That would that help?
Yes. No, you're playing.
Okay. All right. Or maybe it's just low still. All right, tell me if it's any better.
11 by 17 piece of paper, measure in 16 centimeters.
Yes, it is better. So if you
It's
put
better.
it at maximum, it should be.
Okay. All right. Okay. So. All right. All right. Let me start again. All right. So what I'm showing you, see the same thing we did a while ago. I'm gonna show you we can get some art out of math.
Start with 11 by 17 piece of paper, measure in 16 centimeters. From the left side, make a white mark. Line up your ruler at the top of your page in the mark you just made, and make another mark, dark mark at 10 centimeters. This is the mark you're going to use for the entire project. Erase the original mark. Now, send a line out from that dot approximately 8 centimeters. And at the 4 centimeter mark, make a dot on your line. Take a compass, stretch it out approximately 3 centimeters, the sharp point on the 4 centimeter dot, and swing an arc on the line you just drew on both sides. extend your compass out a couple more centimeters with the sharp point where your arc crosses your line, and swing out arc above your dot. Do that on both sides. You are creating a 90-degree angle. You want this line to be 4 centimeters long. From the dot, line your ruler up where the arcs cross with the dot. If I start here at 6 centimeters, then I have to extend my line up to 2 centimeters in order for it to be 4 centimeters long. Now, you've got your first right triangle. Make a line, which would be maybe the hypotenuse. It can be dark here on the hypotenuse portion, but once you hit the dot, you should make a real light line because you're going to end up erasing that. Okay, you're going to start that process all over again. You're going to put your sharp point of your compass in the point here. You want to shrink your compass back down a little bit. Swing an arc on both sides. Stretch your compass open a couple centimeters. Put your sharp point where that arc crosses your line and swing an arc above your dot on both sides. Again, this creates a 90-degree angle. Using centimeters, draw a line that's 4 centimeters from your dot. Make sure you're matching intersection of your arcs. So if I go from 6, I'll go all the way up to 2 to make it 4 centimeters long. And connect that. Again, here's another hypotenuse. Dark until you hit the dot, and then light after that. You'll continue this process, repeating it over and over and over until you come up with something that looks like this, the Pythagorean spiral.
All right. So, as you can see, it's called a what? A Pythagorean. Let me see if I can.
Hello, math student.
Oh, hold on. Let me see if I can.
Start with an 11 by 17 piece of paper. Measure in 16 centimeters. From the left side, make this the Pythagoreans.
Right. If you can look at it carefully, I just pause it. All right. So as you can see, this was the first right angle triangle that she drew. All right, and then she constructed another one. But what you notice about the second triangle? The hypotenuse is a little bit longer, not true? Yes.
Yes, sir.
And then when you draw another right angle, it's going to be what? A little bit what? Longer again. And you keep on doing that. So right here, so is a right angle. So all these are right angles. And you keep on doing that, and it ends up looking like that. All right, well, the horse, the horse is not really you know, that, I don't know where that comes from, but if you were to take out the horse out of the equation, as you can see, it looks like a seashell or a conch shell. All right, and you know, in God's, in all his wisdom, I believe he had a way of designing stuff. And you know, I can safely say that I wouldn't say he used Pythagoras theorem or anything like that, because you know he's God, but he had some mathematical and specific ways of designing stuff. All right, and so this is art in math. All right, and it's called a Pythagorean spiral. All right, so we're almost finished. I soon have to go. All right, so I will finish up at 6 o'clock. All right, so let me see what's happening here. Okay, trigonometry. All right, so this is a little crash course in trigonometry. Just a basic thing. All right, so basically, it's a branch of math that studies relationships involving lengths and angles of triangles. No, I want one of my smart students tell me what is the fundamental difference between Pythagoras' theorem and basic trigonometry. what do you notice? What's a fundamental difference in terms of finding stuff? What do we find in Pythagoras and what do we find in trigonometry? What do you notice? It's right here. It's looking right at you.
The angles.
Right, right. So you see with Pythagoras don't deal anything at all with angles. There's nothing to do with angle. Pythagoras only deals with sides. You know, so I'm stressing on this. You know why? Because sometimes you get questions and you have to apply knowledge to determine what is it that the examiners want from us. Do they want Pythagoras? Do they want trig ratio? So you have to know what you're doing. All right? And they wouldn't give you a question that is impossible to work out. All right? Okay. So trigonometry is actually powerful, not true? Because in trigonometry, we look at length of triangles and what? It's angles, which is very, very important. All right. And some other stuff about trigonometry. I'm not going to go into that. All right. So, okay, I need to sort this thing out. This thing keeps on disappearing. All right. So, our right angle triangle. All right. We have what we call, well, we know about the hypotenuse, right? But you have something called opposite and you have something called adjacent. Right. So, let me see if I can find my marker or highlighter. All right, so we'll finish at 6. I'm just giving a little a crash course, a little introduction to trigonometry, the essence of trigonometry. So in trigonometry, right, we know about the hypotenuse, right? It's always opposite the what? The right angle. But in trigonometry, we're going to introduce something called the reference angle. All right, so the reference angle is this down here, so. All right. So in every triangle, there's always a what? A reference angle. No, the reference angle is, you can easily identify it because they will tell you where the angle is. So you'll know where the angle is. All right. So let me erase this. All right, so this is our reference angle here. This is our reference angle. And on the other side of the reference angle is what we call the what? The opposite. Meaning it's opposite the reference angle. And on the other side is called the adjacent side. All right. Okay, so let me just tell you something. Is it the adjacent side? Because let me tell you, students get these things mixed up all the time. So here we are. No, we're positive that we know what we can locate the hypotenuse, right? We're positive. But what sometimes we have problems is locating the other two. All right. No, is it the adjacent? There's a way of knowing exactly where the adjacent is. Listen carefully. The adjacent side is always between the right angle and the reference angle. So if you know what the hypotenuse is and they tell you the reference angle, you can locate the adjacent side. What did I say? The adjacent side is always between what? The right angle. There's a right angle, not true? And the reference angle. Now, if you know the hypotenuse and you know the adjacent side, then the other side must be the what?
Opposite.
Must be the opposite. All right. All right, so let me see. Let me test your skills. Let me see if you guys. Let me see if we can draw one little thing here before time run out for me. All right, let me draw a little right angle triangle right here. All right, so this is my reference angle. All right, I have A, I have B, and I have C. All right, now A, B, and C. One is either opposite, adjacent, or hypotenuse. Tell me which letter matches with which word. In other words, what is
Sir, B is opposite.
very
And
good.
C matches adjacent. And A matches hypotenuse.
Right, very good. Why did you say B was the opposite? I wanted you to give me all the reasons.
Sir, because this, what you call the little something again?
It's called a reference angle.
Yes, sir. The reference angle is the opposite is always opposite to the reference angle, if that makes sense.
Right. So right, very good. Yeah. So the opposite side is always opposite the reference. All right. And how did you get the hypotenuse?
The longest side, and it's opposite to the right angle, so it's the hypotenuse.
Right. And then if you know the hypotenuse and you know the opposite, then the other side must be the adjacent.
Adjacent.
Right. Thank you very much. All right. So, but let me tell you something. You know why I wouldn't. You know why I don't like to find opposite. Let me tell you why. Some people, I don't know, but sometimes some persons who like they overthink, and them say, "All right, sir, where is the opposite? Sir, see opposite right here, sir." I may ask them why. Because it's opposite the opposite reference, not true. Them say the opposite reference. I don't know why them say that. But looking at it, it's a possibility, because if the reference angle is right here, what is wrong if to say that over here so is the opposite rather than way over there, so? I don't know if you guys following me. All right, but sometimes when we're finding the opposite side, there's always a little gray area. All right, so what I do, I scrap the opposite and I say, you know something, let us try to find the adjacent. All right, now the adjacent we know is always between what? The right angle and the reference angle. So look here, this is the right angle, not true? And this is the reference angle, so therefore C must be the adjacent. So if you know the hypotenuse and the adjacent, then that must be the opposite. All right, so ladies and gentlemen, that's my little crash course in Pythagoras and a little thing in trigonometry. I hope you learned something, or if you knew some of these things here, you get a little refresher, and All right. So do we have any questions?
Sir, for next week, are we going to try some trigonometry questions?
All right. If you want me to, I could continue. I could actually continue. All right. Yes, we could. I didn't get a chance to actually answer any trick question because of time, because I spent a lot of time on the Pythagoras. But it's very important to understand Pythagoras to understand trigonometry, because they're very, very much connected. All right, class. So Mr. Green, I believe, had left. I still see him logged in. I think he's logged in, but I think he physically had to leave the location. All right. So without any further ado, I will see you guys around. So thank you for joining, and I'll see you around. All right. To take it easy.
Bye, sir.
All right. Bye bye, Selena.